remember I did the problem previously where I said this reaction going to this was spontaneous. So this is the non-spontaneous reaction. And when you calculate delta G here, notice I didn't ask you for what is Ecell, because, or what E0 cell was, because it has to be a positive number. This won't come out positive. So that's why I didn't ask you. I mean, this will come out negative. So this delta G0, what do we say it was, 10 electrons or something, 10 electrons. And I forget what we had, oh, 0.02 volts. So now this makes delta G positive for this, which again tells you it's the non-spontaneous reaction. If you just took the larger minus the smaller, this minus this, it said 0.02 volts, but that means this is the one you would have to reverse. But I gave you the one where vanadium is still on the right side instead of reversing. So all I did was give you the non-spontaneous equation. And I didn't ask you to calculate Ecell for the non-spontaneous reaction, but I did ask you to calculate delta G because you already know you can have positive or negative values for delta G, because that just goes with the equation. But when I put things together in an electrochemical cell, the only thing that ever happens is the spontaneous reaction, or nothing happens. That means what? You're in equilibrium. Okay. Doesn't go one way or the other. It's reacting. We have what we call the dynamic equilibrium, but there's no net change.
Because they're both occurring at the same time.
Yeah, forward and backwards are occurring at the same rate, so things are disappearing as fast as they're being formed. That's where the rate business comes in. Okay, so now coming back to this thing, for number 4 now, the answer would be, how many electrons? 6 electrons. And we calculated 1 volts at standard state. Okay. Then delta number 5. And sure enough, there's my cell potential, plus 0.0576. And notice, this will come out negative, this will come out negative, but it's not going to be as big a number as this one. In absolute terms. To change this around, change the concentrations a little bit. I think I changed them enough. I'll find out in a minute. Because now I'm going to do the problem. In other words, all I'm doing is changing my concentrations a little bit. Minus nope, I didn't make it small enough yet. I make this -4. But it's still going to come out positive. I want to get something negative. expand this, it now comes out to be 0.100 minus 0.107. And this is what I call Ecell calculated. It's that minus 0.007 volts. But what it means is Ecell is now 0.007 volts because I had the wrong reaction here. In part, where am I? Here, part 3, right? The reaction I would have to write now would be the reverse reaction. So these two numbers now go together. This is the spontaneous reaction in the cell, and this is the cell potential. As I say, when you're doing electrochemical cells, the only thing that happens is the spontaneous reaction. The electrons are either going to go one way or the other. You can't go both ways. And if you're at equilibrium, of course, they're not going one way or the other. They're not going. Okay, they're just standing there. You can't turn on the radio or start your car. So now with this new set of things, if I ask the same questions for number 3, all you'd be doing is putting in the different things. They'd be, for instance, if I ask question 3 for this reaction, calculate delta G0 for the reaction in 3, that's the standard state. What do you know about delta G0 for this reaction? Sine-wise. Well, for the one we did just a few minutes ago, it was a negative number. It's going to be the same number, but now it's going to come out with a positive sign because I reversed the equation. Okay. So that's why you want to think what's happening here. In standard states, for the original problem, this was the spontaneous reaction. When I did the calculation for this problem, I started with the same reaction here, okay, and I calculated a negative number. Since I calculated a negative number for Ecell, it said that wasn't the spontaneous reaction, this is the spontaneous reaction, it reversed. But at standard states, this reaction would have had a positive delta G because it's not spontaneous at standard states. But notice, at the delta G for this would still be what? A negative number using this in the calculation. Minus NFE calculation. So for that reaction, under the conditions of the cell, notice I changed the cell conditions drastically. I changed this to minus, by the way. So I can show you that it will eventually change. Okay, have we beaten that one to death enough? All that's left for you to do is a bunch of problems. I've done all the problems I can do with it that I can think of. So now you get to do the problems over the next couple of days. Okay? So coming back to that,